Hello everyone, I'm Carlos Cuartas, and this is the presentation for the Autonomous Pong project. My project was to make a cup tracking robot that shoots ping pong balls into cups using machine learning. I designed this robot to demonstrate the capabilities and preciseness robots can have when using machine learning and computer vision paired alongside the capabilities of launching. It can perceive cups, calculate distance and location, and even decide at what strengths to launch ping pong balls in order to accurately make them inside of cups. This robot can be broken down into two important functions, the launcher function and the cup tracking function. Since this is one project split between two classes, I will be covering only the cup tracking function for this presentation. The main purpose for this function is to point the barrel at the targeted cup by rotating the base of the robot. Though this may sound simple, there are many challenges that it has to overcome, like low lighting tracking and object occlusion. For the hardware part of this robot, the yaw aiming function works by utilizing four things: a normal web camera, one servo motor, a rotating base, and many different types of object tracking techniques. The base, in theory, is a lazy Susan with a geared servo motor attached to it to rotate it. The robot knows where to turn based on if the tracked cup is to the left or to the right from the center of the screen. I had also tried many methods of object tracking and will go over my attempts from simplest to the more advanced. Object tracking at its most rudimentary stage generally functions by doing some basic hue saturation value filtering within a range and then by tracking the largest area of mass. This technique is simple and lightweight, though doing this makes all attempts at tracking in any other lighting nearly impossible, thus leading me to try out other methods. In order to qualitatively compare these results, I created 6 environments for this testing. These environments will contain obstructing and non-obstructing environments, paired alongside bright, dim, and dark lighting conditions. I started off my actual testing using YOLO version 5 from Ultralytics, a spin-off of the original YOLO. Using the benchmark environments, I tested the default model trained on the COCO database. As you can see, the COCO model can detect cups with a lot of false negatives and false positives. This pushed me to explore other methods like creating my own model in order to improve results. Once I was done training a custom basic cup model, the results appeared to be a little better than the COCO model, but only for the clear and bright environment. All other environments using a basic cup model were worse compared to the COCO model. In order to improve this, I retook photos and included many different types of obstruction images in hopes of increasing the ability to track obstruction environments. Sure enough, the obstruction environments was a cakewalk with this new obstruction model, but all other environments were severely worsened with this new dataset. In hopes of improving all environments, I combined the dataset from the basic cup model and the obstruction model and also included more images from several different types of lighting to try to get the darker environments to work better. These are the final results for the lighting model. As you can see, all environments improved tremendously in terms of tracking. The bright and dim tracking became smooth and nearly 100% accurate, and the dark environments can detect cups now despite the total lack of light in these videos. The results were quite similar to what I originally hypothesized, but still shocking. I understood from the beginning that tracking in the darkness where humans struggle to see anything would be nearly impossible, but the results impressed me nonetheless, since it could even track it in the darkness at all. In conclusion, thanks to this research, I can now apply this model to my robot in order to track cups in all lighting environments, and to top it all off, I can even track cups with objects obstructing the way. This concludes my presentation. Thank you for listening.